Hey, welcome back to my channel. If you haven't subscribed, please hit that subscribe button. So this question is asking you, knowing that a human eye has an osmotic pressure of 7.97 atm at 37 degrees Celsius, an eye drop solution with the same osmotic pressure and temperature is prepared by adding 0.242 grams of sodium chloride in 25 ml of water. Calculate the Van Hoff factor for NaCl in this solution and assume that the density of the solution is 1 gram per milliliter. The molar mass of sodium chloride is equal to 58.44 grams per mole. The osmotic pressure given in the problem is equal to 7.97 atm. And the temperature, which is given in Celsius, has to be converted into Kelvin. So that will be 37.0 plus 273 Kelvin. And that is equal to 310 Kelvin. And the equation for osmotic pressure is equal to pi I, the molarity, the rate, which is a constant, and the temperature in Kelvin. So the value that we're trying to find is I. So we'll just rearrange the equation to give us that value. So I will be equal to the osmotic pressure over the concentration, or the molarity, times the rate, times the temperature in Kelvin. So before we input any values into the equation, we have to figure out the amount of moles provided by the sodium chloride. And that can be given by the mass of sodium chloride divided by its molar mass, which is equal to 0.242, which is given in the problem, divided by the molar mass, which we found from the periodic table, where the grams will cancel out to give us a value of 4.1409 times 10 to the negative 3 moles. The concentration of sodium chloride can be found by taking the moles of sodium chloride and dividing it by the volume of solution provided, which is given in the problem. So the moles which we found here was 4.1409 times 10 to the negative 3 moles divided by 0.025 liters, or that's 25 ml, but that has to be converted to that. And by performing that math, we get a concentration of 0.1656 molarity. So going back to this equation, where I, the osmotic pressure, is equal to the Van Hoff factor, the molarity, the rate constant, and the temperature in Kelvin. So the Van Hoff factor can now be found by just plugging in the values which you calculated earlier into this equation. So the osmotic pressure was 7.97 atm. The molarity is 0.1656. That'll be times by the rate constant, which is a value that can be found in any textbook, 0.08206, times the temperature in Kelvin, which is 310. And this should give you a value of 1.89. And that's the final answer.